Welcome back to TI Now's Connectivity Series, and with us today is Ira Brodsky of Datacom Research talking about what's next for 5G. And Ira, welcome to the program.
Thanks for having me.
Well, thanks for being here. I want to start by asking, as we move closer to 5G networks, let's say over the next 5 years, it seems that the capacity issue is the most pressing. Is 1,000 times increase in capacity a level that the wireless industry should really bet on by 2020?
Well, I think that the 1000x goal is really kind of the grand target for 5G. I wouldn't expect it in 2020. I think what we're looking for is for 5G technology to carry the wireless industry all the way to 1000x. And then by the time that 6G comes along, we'll look for further increases. But it's really a fantastic goal when you think about it, because when the industry first upgraded from 1G to 2G, the goal was only 10x. And usually as technology matures, it becomes harder to achieve these giant leaps in performance. And yet here you have the industry, a very mature industry with very sophisticated advanced technology, setting a goal of 1000x. And that's why I think 5G is so multifaceted, that it's going to have to require many different types of solutions to add up to 1000x.
Ira, you said in a recent Computer World article, authored by you, in fact, that high and low frequency bands will be necessary for 5G. But you also said that low frequency bands that can, travel along long distances and around corners will be available only in the short term. What's the significance of that?
Well, I guess I'm really saying that in the short term, the focus will be on the low frequencies because the electronics is less expensive, and there's a lot of further research to be done in terms of operating at very high frequencies. So the low frequencies, though, a lot of that spectrum is already allocated. However, the good news is that a lot of it was allocated decades ago, long before there were billions of mobile phone users and hundreds of millions of wireless LAN users. And so there are a lot of opportunities for refarming the spectrum. For example, that's going on with the TV spectrum now, and also making more efficient use of the spectrum, getting twice or three times as many users into the same block of spectrum, and new technologies for sharing spectrum. One of the hot issues right now is controversy, really, is the idea of cellular sharing some of the Wi-Fi spectrum. A lot of people think that that's a great idea. It'll also make it easier for the Wi-Fi industry to interoperate with cellular. But there's some people who are worried that it's an attempt by the cellular industry to muscle their way into the Wi-Fi frequencies and maybe take them over.
Let's talk about some of those technologies, Ira, that'll facilitate the future for 5G wireless. I want to focus on MIMO technologies for 5G networks. How much of a role will MIMO play?
I think MIMO is going to play a very big role. MIMO was a very unexpected breakthrough that came about in the mid-1990s. A guy named Greg Raleigh was researching smart antennas and channel models, and he came to the conclusion from a new channel model he developed that the capacity of radio spectrum is greatest in the presence of multipath interference. And for 100 years, engineers had always believed that multipath, not really interference, but multipath propagation, engineers had believed that that was a problem to be eliminated or at least minimized. And this discovery said, you can actually use those multiple paths to send multiple streams of data at the same time. And so that's how we've gotten these new Wi-Fi and cellular standards like 802.11n, 802.11ac, and LTE Advanced. These technologies are able to transmit at hundreds of megabits per second and even over a gigabit per second. And those speeds would have seemed impossible just a couple of decades ago. So I think what you're going to see in 5G is much more aggressive use of MIMO, something called massive MIMO, where you're going to have cell sites, outdoor cell sites with very large numbers of antennas, maybe 1,000 antennas on one cell site. And you'll also see another technology called multi-user MIMO. That's basically a way to, well, one of the problems that you have in any kind of radio system is it's a shared medium. So if you have a channel that's running, let's say 500 megabits per second, and you have 100 users on that channel, they're not even going to get 5 megabits per second each. With multi-user MIMO, you can begin to split up those users. The peak speed is lower, but the average speed goes up. So I think MIMO will play a very big role in getting to the really high speed applications, but still, MIMO, if it increases capacity by 10 times, it's not enough. So we still need these other technologies like more spectrum sharing, and the like.
Ira, I want to talk about the explosion of the small cell market. I really want to talk specifically about the growth in the timeline of the small cell sector. Are we very early in that growth period? Are we sort of in the middle somewhere, or are we at the later stages?
Well, I think we're still in the early stages, although Wi-Fi is very popular as an indoor technology. But the thing to keep in mind here is that the industry is now 30 some years old. We've built out great outdoor coverage. Great indoor coverage is the next challenge. And also, if you can bring the signals closer to the users, you get better performance. And the thing is that the mobile industry has changed so dramatically. When it started, it was for car phones exclusively. And today, it's all handheld devices. And those handheld devices are being used mainly indoors. So the networks that were built to provide all this expansive outdoor coverage still don't necessarily provide coverage where people expect it most. And so I think we're going to see a number of different solutions for indoor. We are seeing a number of different solutions interoperating with Wi-Fi, but also this Wi-Fi, this LTE in unlicensed spectrum. I think we're going to see some new frequencies being used, frequencies where the original allocation was for a user that's primarily outdoors. And if you're operating exclusively indoors, you're more likely to be able to reuse the frequency without interfering with outdoor users. So this is kind of the next big frontier for wireless development. And it also creates new business opportunities. There's internet companies that are able to basically create almost ad hoc mobile phone service by stringing together either Wi-Fi or a combination of Wi-Fi and cellular. And I think you're going to see more and more of that kind of activity.
Ira, you mentioned at the top of the program about possibly not seeing 5G networks come to fruition by 2020. What are some of the industry trends that could alter the path of 5G wireless?
Well, it's always a good idea to plan, but it's also a good idea to plan for the unexpected. And the industry tends to try to map out a timeline and come up with very specific ideas about how everything is going to evolve. But there's always new competition, new technologies, new applications that could change those plans. I think most of those things are good things rather than bad things, though. A couple of companies that I see out there that are doing some very interesting things. One is a company called Kumu Networks, and they basically developed a technology for that can double the capacity of the radio spectrum. And the way it does that is it allows a device to receive while it's transmitting on the very same frequency at the very same time. And that's done by subtracting out the roar of the transmitter signal so that you can hear the whisper of the distant signals. So that's a very powerful technology, but it remains to be seen how well that works in practice. Another very interesting and very controversial company is Artemis Networks. They've developed something called the P-cell, or personal cell. And this technology actually exploits interference. And they believe that they can achieve much higher performance than LTE or massive MIMO. And they do that by looking at the signal. It's a cloud-based system. They look at the signal that the mobile device is receiving. And that signal that they're looking at includes all the interference. Instead of trying to overpower the interference, they try to add the desired signal on top of the interference until you get a combination of interference and desired signal to create exactly what you want. Very, very intriguing idea, but it's only been tested under controlled conditions so far. So we await for them to really let people kick the tires.
Ira, TIA Now's connectivity series is geared towards progressive technologies, and 5G is certainly one of those. So we appreciate you coming on our program. Thank you.
Thank you for having me.